All right, guys, second video. Okay, so we start running into some problems with functions like this. Obviously, notice we don't have a linear function, so it's not like the real easy ones, okay, that we did in the last video. And one of the problems we run into is we have some issues with domains and ranges here. That and the fact that you guys haven't learned how to graph these things yet. You will this year, I can promise you that. Okay, so you might want to take a look at getting some additional help, okay, maybe using a graphing calculator if you have. I know some of you have those. Okay, you could graph that on a graphing calculator and take a look at it, might help you out. Or you could also go to Desmos, okay, and use that as well. And I know you guys have used Desmos in the past, okay, in some of your classes. Okay, so like I said, down the road, I'll teach you how to graph these. We just haven't gotten there yet. Okay, so I know that this guy, and obviously I took a look at it on Desmos, okay, to just save some time. Okay, now notice how the denominator will end up being 0 when x equals -1. Okay, so that -1 gets thrown out of the domain right off the bat. And so that means that we have a vertical asymptote, okay, at x equals -1. Okay, we've got this vertical asymptote. And I know I brought that up earlier in the year when we were talking about looking at graphs and figuring out domains and ranges. I know I brought that up, okay, and I told you we'd be seeing more of it, okay, later on in the year. This also has a horizontal asymptote, okay, at y equal 1. Okay, so I have this horizontal asymptote. And I know you guys are, you don't really have a full understanding of those guys yet, and that's okay. And if you take a look at what the graph of this guy looks like, either on a graphing calculator or a Desmos, okay, it's going to have a curve up here in the upper left-hand corner like that, and then it's going to have a curve down in the lower right-hand corner. It's going to kind of do this, okay? And so just looking at it on either a graphing calculator or Desmos will help you out a little bit, okay, when we get towards the end of this problem. Because what ends up happening is, can I find an inverse? Yes, absolutely. Will that inverse work everywhere? Probably not, I'll be honest with you, probably not, okay? So, does this guy, okay, pass the horizontal line test? Well, it certainly looks like it does, okay, because it looks like all horizontal lines will only intersect it once, okay, so it might work out, it might not. I just know once you start getting into these rational functions, okay, we've got some issues with getting the domains and ranges, okay, to work out, okay, so we'll talk about it, okay. Finding the function isn't really any more tougher, okay, than the other guys. Okay, so we took a look at what does it look like. Okay, that guy could come in handy down the road. Okay, and so I say, okay, well, what do I want to do next? Well, the first thing, get it out of function notation. Okay, so replace the f of x with y. So I get y equals x minus 4 over x plus 1. Okay, the next thing we do is switch all the x's and y's. Okay, so that y becomes an x. Okay, this guy becomes a y minus 4. Okay, and down below we get a y plus 1. Okay, so now I've got to solve for y. Okay, so there's a number of different ways. Obviously, we want to get rid of this fraction. Okay, so I could treat it like a proportion and write it as x over 1, and I could just take the cross products, okay, to get rid of that fraction. Okay, so x times y plus 1 has to equal 1 times y minus 4. like that. And obviously 1 times y minus 4 is just y minus 4, like that. Okay, now I have to isolate y. Okay, that's what I need to do. So I have to get at this y. Okay, so how about we distribute the x? So I get x times y plus x. Okay, so far so good. It's just algebra 1. All right, now I have this term and this term both have y in it. Okay, so I need to get those two terms on the same side and get everything else on the other side. Okay, so what if I bring this guy over? Okay, so notice it goes from positive to negative. So I'd have xy, which is already there, minus the y. Okay, now if I want the terms with y on the left-hand side, I got to get everything else on the right-hand side. So get this guy out of the way. So take that x that doesn't have a y in it, move it over to the right side so it becomes negative. Okay, now, why do I want to do this? Well, I want to isolate y, so the only way I can do it is to factor it out as a GCF. Okay, so if I factor it out on the left-hand side, okay, I'll be left with x minus 1. Okay, and then what I can do is I can divide both sides by x minus 1. So I get y equals negative x minus 4 all over x minus 1. And notice that I've isolated y now. Okay, so I go back to function notation, and remember this would be an inverse, so this would be f inverse. So f inverse of x equals negative x minus 4 all over x minus 1, okay? All right, and then, okay, you've got your function that acts as an inverse, okay? The problem you run into is doesn't act as an inverse all the time, okay? That's the tough part about it, okay? So if we go to our original function f of x, okay, and I look at the domain and the range right here, okay, well, if I go up here, notice the domain, okay, everything works other than x equals negative 1, okay? So I could say, okay, well, the domain would be negative infinity up to negative 1, and we don't include that, union negative 1 to infinity, okay? And then if I look at the y-axis, everything would be accounted for other than y equals 1. Okay, so the range would go from negative infinity on the y-axis all the way up to 1, and then we skip 1 and we go from 1 to infinity, like that. Okay, then you look at f inverse of x. Okay, now I would go to either graphing calculator or Desmos, go to one of those guys and see what it looks like. Okay, obviously this guy right here is your f of x. And so if we do our f inverse of x, you know, what does it look like? Okay, and I'll punch this up on Desmos. Okay, I'm right at my desk. Okay, now I know, for instance, I know I'm going to have a vertical asymptote at x equals 1. I know I'm going to have this guy right here, x equals 1. And I'm going to have a horizontal asymptote, okay, at y equals negative 1. I know that, okay? And if I punch it up on Desmos, let's see, okay, I'm pretty sure it is going to be down here and up here, if I remember right. Let's see, a positive number, yes. Okay, it's going to be down here. Okay, and then it'll be up here, like this. And again, I know you guys won't know that off the top of your head, okay? So you got to either go to a graphing calculator or Desmos, okay? And let me make sure. I'm sort of working through this in my head, and I'm pretty sure I'm in good shape. Yes, this is good. Yes, okay, that's where it'll be. Okay, so if we look at the domain and the range, okay, of this guy right here. Well, the domain, notice it's going to be everything along the x-axis other than this x equal 1. Okay, that's the only thing. So it would go from negative infinity to 1, and we throw that guy out, 1 to infinity. Okay, and then if I go to the range, notice it's going to be everything along the y-axis other than this negative 1. Okay, so we go from negative infinity on the y-axis up to negative 1, and then we union that with negative 1 to positive infinity. Okay, and then we just take a look. Okay, does this domain of the original function give us the range, okay, of the inverse? And notice they're exactly the same. Okay, so things work out with this domain and that range. So then I look at the range here of the original function. Is it the same as the domain, okay, with the inverse function? And notice they're exactly the same. Okay, so this is an example of one of these guys where things do work out okay. Okay, that's not always going to be the case. Okay, sometimes you have some problems. Okay, the important thing is that you can do this. Okay, this is the important thing. Okay, and sometimes this gets a little muddy, and we'll get that cleared up obviously as we go through this stuff. Okay, so let's take a look at another one like this. Okay. All right, so let's see. Okay, if I take a look at the original function, okay, and again, okay, go to Desmos or your graphing calculator and punch it in, okay, and take a look at what it looks like. Okay, notice if x is equal to 5, okay, then I get 5 minus 5 or 0 down in the denominator, which obviously you can't have 0 in the denominator. So if x equals 5, that gives me a vertical asymptote, okay, at x equal to 5. Okay, so I'm going to get this vertical asymptote at x equal 5. Okay, I know that. And again, I'll be teaching you about that down the road. Okay, horizontal asymptote. I know I have a horizontal asymptote at negative 1. Okay, so I got a horizontal asymptote at negative 1. And again, okay, go to Desmos or go to your graphing calculator. And let's see what's going to happen. Okay, so, okay, down here we're going to have a curve that looks like this. Okay, and then up here I'm pretty sure, yes, okay, it'll be like this, doing this. Okay, all right, and again, I know that you guys might be a little shaky on that. Okay, I'll teach you how to do all that stuff down the road. So if you look at horizontal lines, it looks like it passes the horizontal line test, where no matter what horizontal line I take, okay, it'll only intersect the graph once. So things might work out okay like they did on the last one. Okay, so let's see. We take the original function, get rid of function notation, replace the h of x with y. So we go y equals 9 minus x over x minus 5. Okay, now we switch the x's and y's. So this y becomes an x, and both of these x's become y's. So I get 9 minus y over y minus 5. Okay, now again, there's more than one way to get rid of that fraction. It's just a matter of how you want to do it. I like to use cross products. Okay, so write it as a proportion, and we just take the cross products, okay, like I did on the last one. Okay, so I'd have x times y minus 5, x times y minus 5 equals 1 times 9 minus y, so that's just 9 minus y, like that. Okay, now I have to get the terms with y together on the same side, so I can factor it out as a GCF. So I got to get rid of these parentheses. So I distribute the x, so I have x, y minus 5x equals 9 minus y. Okay, so I have to get this term and this term together on the same side. So I'm going to leave that term on the left, and I'm going to bring this guy over. Okay, so I'm collecting all the terms with y on the left-hand side, which means everything else has to be on the right-hand side. So this guy has to move over to the right. So when I do that, I get x, y, this would become plus y, equals, that'll go over and become positive, so that's a positive 5x plus the 9. And then factor out a y. Okay, so we factor out a y, and I'm left with x plus 1 equals 5x plus 9. And then divide both sides by x plus 1. So we get y equals 5x plus 9 divided by x plus 1. Okay? So now I just go back to function notation, and this is an inverse. Okay? So this guy becomes h inverse. So h inverse of x equals 5x plus 9 over x plus 1, like that. Okay. All right, so I have my inverse function. Okay, now we just have to look at the domains and ranges of not only the original function, but of the inverse, and see what happens. See if things work out nice like the last time, or if things get a little crazy. Okay, so if I look at h of x, and I look at the domain and the range. Okay, so if I go up here, the domain, well, everything along the x-axis works other than 5. Okay, so the domain would go from negative infinity up to 5, which we throw out, and then union that with 5 to infinity, right there. Okay, so the range along the y-axis, everything works other than y equals negative 1. So we go from negative infinity to negative 1 and union that with negative 1 to infinity, like that. Okay, now I do the same thing with h inverse of x. And again, looking at the graph of this guy, again, you know, go to Desmos, go to your graphing calculator, okay, take a look at it, okay. I can give you a general idea of what it looks like. Okay, so right here, notice when x equals negative 1, the denominator will be 0, which I can't have. Okay, so I have to throw out negative 1, okay, along the x-axis. So that means I get a vertical asymptote here at x equals negative 1. And I know I have a horizontal asymptote at y equals 5. So everything will work out other than y equals 5. And so I take a look at, you know, where is this guy going to be, okay, in the graph. And let's see, if I take, okay, that's going to be positive. Okay, so this guy's going to be up here like this. And if I take like a negative 2, let me see. Okay, that guy will be right here, I think. And I'm just doing that in my head. Okay, so we take a look at what's going on with the domain and range here. Okay, so the domain, everything along the x-axis works other than x equals negative 1. So that would go from negative infinity to negative 1, and then we throw negative 1 out and union that with negative 1 to infinity. Okay, right there. Now the range, everything's going to work other than y equals 5. Okay, so it's going to go from negative infinity all the way up to 5, and we throw that out and union that with 5 to infinity. And then we take a look. Okay, does the domain here give us the same thing as the range down there? Yes. Does the range here give us the domain down here? And that would be yes. So everything works out. It's clean like the last one. Okay? All right, so let's see. I'm going to wrap that video up. We got one more I got to make. I know you guys heard my phone ringing. Sorry about that. I can't shut that off, unfortunately. So I'll get this one posted, and then we got one more we got to do.